All right, so there are a few things to look at. We're going to look at what we call factors of a number. All right. So a factor is basically, well, a factor of a number are those numbers including 1 and itself, which can be divided exactly. Well, exactly into the number, basically. All right. Example. Find the factors of 40. All right, anybody want to give it a try? What are the factors of 40?
2, 5, 10.
Hold on, you're going. Remember, I have to type here.
Okay,
Come on.
so
Yeah. Hold on. Let me check something. Yeah, go ahead. 1, 2.
5, 5.
You sure let me sort something?
4.
Oh yeah,
4.
4. Yeah. 5, 10.
You sure let me sort something?
Yes.
Yeah.
8.
10, 20.
Correct. And
Okay. Itself.
itself, which is 40. Awesome. All right, so those are factors of a number. All right. Now, you have something called highest common factor, or as you know, popularly known as HCF. All right. So basically, if I say to find the highest common factor, it would be a set of numbers as well. All right. So it will be more than one number. So for example, find the HCF of let's see, 15, 18, and 21. So basically, what you're going to do, see, is to find the factors of all of them first. So you find the factors of 15. You find the factors of 18. And you find the factors of what? 21. All right. And what you do, you see, it's like one list them out up here, so
That would be 3.
all right. Okay, you saying 3?
Agree.
Agree. Okay, all right. Well, you guys are like bullets. So so it's gonna be 1 and what? 3
3, 5,
and 15, right?
15.
What about this one?
1, 2, 6.
What else?
9. 18.
And 18.
Right. But 21 is 1, 3.
7.
21.
All right. And as you can see, well, one is a common factor, not true? 1 is a common factor, and 3 is also a common factor. But 3 would have been the highest factor that is common among what? All 3 numbers. All right. So let me just highlight that. So answer.
Sir, I don't understand.
All right. What exactly you do? Do you understand? You get how we got these numbers here?
Yes, sir. I don't
Mhm.
understand like where the 1 and the 3 and the 5 and the 15 come from.
Oh, so in other words, you don't understand how I get these numbers because I just asked if you understand. You said yes. So you want me to explain how I got these numbers from?
Yes, sir.
All right. So what is first of all? So the definition of a factor. What does the factor of a number mean? Read what it says. Factors of numbers are those numbers what? What it says?
Include 1 and itself.
Right. So factors of a number are those numbers, including, so you have other numbers apart from 1 and itself, which can be divided exactly. What does that mean? Do you know?
No, sir.
You don't know? It means that when you divide it, you don't get a remainder. All right. So what happened is that for 15, can 1 go into 15 without leaving a remainder?
Yes, sir.
Yes, right? Can 15 go into 15 without leaving a remainder?
You can go in 1 time.
Right. And there's no remainder, right? Am I correct?
Yes. 15.
Mhm.
Can be.
Right. So therefore, when you're finding factors, 1 and itself are always factors of a number, correct? And then now, using your knowledge of your multiplication table, we recognize that 3 can go into 15 also. All right. And we also recognize that 5 can also go into what? 15 without leaving a remainder. And I do the same thing. I do the same thing for 18 and 21.
find my headset using.
All right. I hope you're following here. Can you mute your microphone, please? All right, thank you. All right, so so ma'am, do you want me to explain how I get the numbers for 18? You want me to explain that also?
I understand now. Numbers that can go in 18 without leaving a remainder.
Yeah, man, that's the definition of what a factor is.
Yeah.
All right. And then what happened now? What you do is you write out all the factors, and the question says what is the highest common factor? So if you look at all those numbers, you realize that 1 is a common factor and 3 is also a common factor. So 3 would have been the highest common factor. All right, ma'am?
That's true enough for that one.
Well, 3, yeah, yes, you're correct. It's higher, basically. I would say no for, It's the same thing, but it's more than 1. Okay. All right. All right. So that was factors of a number. Sorry, that was highest common factor. So we want to look at what we call multiples of a number now. So multiples of a number. Well, it's pretty simple. Basically, if you want to find the multiple of a number, so we simply add the original. Well, we keep, well, we constantly add the original number. To the previous one. All right. So if I say, example, find multiples of, say, I don't know, say 5. It would have been what? 5. You keep on, right, 5, 10, 15, 20, 25, etc., etc. So you keep on adding the same number. All right, so this is pretty straightforward. That's how you find the multiples of a number. So if I say, what are the multiples of, say, 11? 11,
22, 32, 30, yeah, all for answer.
All right. Let me ask a question. Can I ask you to find the highest common multiple? We have highest common factor, not true? But can I ask you to find the highest common multiple?
Yes.
Yes.
All right. One person said yes.
Sure, you know, go on and on and on and on and on. You can't go find that. Go wait for
Yeah, that, yeah.
Okay, yes, correct.
Different numbers as you go
Right.
along.
Because look here now. Remember, so the multiples don't stop, you know. It doesn't stop. So if I say find the highest common multiple, you're gonna take from eternity because numbers are what? Continuous. So you wouldn't hear anybody or you wouldn't get a question that says, what is the highest common multiple? You'll more hear say what? What is the highest common factor? Because multiples are what? Continue and continue. All right. So rather than asking for the highest common factor, rather than asking for the highest common multiple, what do you think they want to find? Rather.
the lowest.
All right, the lowest common multiple. Get it? That makes more sense, don't you? Not the highest. So then we'll move on to the lowest common multiple, or popularly known as LCM. All right. So if I say, so example, if I say find the LCM of the following numbers. All right, suppose I say 4 and say 6. All right. To find the LCM, I say, what you do is that you find the multiples of 4. What are the multiples of 4? 4, 8,
12,
12,
16,
16, etc.
no, 20.
And then let me continue. 16, then 20, then 24, then what?
28,
28, then
32.
all right. Then 6 no. Multiple 6 are 6, 12, 18. What next?
24,
24. 30,
36,
36. Let's stop there. All right. So the question says, what is LCM? All right. So the LCM would be the common multiple. No, we have for this
12.
we have 24 is a common multiple, not true? Look at 24. It's common, not true?
Yes.
And we also have what? 12.
12.
But what the question says find the what? The lowest.
Lowest.
Right. So the lowest is what? 12. All right. So therefore, the LCM is equal to 12. All right, try something. Find the LCM of 6, 9, and 50. What's the LCM? Let me give you about 3 minutes to do that.
Sir, 3.
3?
Yes.
sure?
Very.
I'm get 90, sir.
Come on, it's 90.
Yeah, 90 it is. Going along.
90.
90. I don't understand how you get 90.
Where's the
All right,
lowest?
all right. Tell me, explain how you get 3.
You said the lowest common multiple, and
Mhm.
3 would then be the lowest one in all of them, all of the 6, the 9, and the 15.
Come on, 3 is not a, hold on. What are the multiples of 6?
She
You have
did the
1.
Hold on. What are the multiples of 6?
6,
12,
12, 8,
18.
20.
What are the multiples of 9? 9, 18.
Okay, I did it wrong then.
Okay, it says,
27,
right.
36.
Thank you. So it says lowest common multiple. All right.
Yeah.
Not what so what you did a while ago was to find the common factor
Yes.
or the lowest common factor. That's what you did a while ago, you know. 3 would have been the lowest common factor. Well, it would be 3 because 1 would be the lowest common factor.
Oh, yes. That's
it
true.
would-
1
it
would
wouldn't
have
be 3.
been.
It wouldn't be 3
Yeah.
either. It would be 1 because 1 can go to all of them.
Yeah.
I think probably the highest common factor would have been 3. I think that's what you're finding. You're finding the highest common factor. All right. But you guys worked on that fast though. All right. Let me give you another one to try. Find the LCM. Of 2, 3, 5, and 8.
One.
1 will be the lowest common factor. You follow?
Okay, sir.
Yeah. Not, yeah.
30, sir.
Can 8 go to 30? Told you. So 8 can't go to 30, so that won't be correct.
Forty, sir.
40.
All right, can 3 go to 40?
No.
Come, who am I? If I was in class, I probably took out some money and one start bet.
$24.
Can 5 go to 24?
She went see
60, sir.
All right. Can 8 go to 16?
No, sir.
124.
Sorry, 120.
No, it's 120. Where the 124?
120 mean, sir.
Eh?
120 did mean.
Okay. So if you go to Cambio, right? And you get a cashier 124 US. We're gonna tell her, say, come on, nobody with the 124. I want to me. All right, okay. Yeah, it's 120. Anybody want to share us a fast way of getting it? Because to sit down and write out and something. What did he do?
All right, so I use the 8 to actually check 8. Most of the numbers I've gotten, I've checked the ones that the 5 can go into, but I mostly check for the 3. what the three can go into. So most of what the three can go to the positive.
Do not hear you.
Oh my, man. Well, I think I might need hearing aid. I don't know what's happening in the background. The background's a bit noisier. Anybody else want to share with us? Well, I think what she was saying, she started with the highest number and just keep on adding. I think that's a good way. You know, I mean, 2, 3, and 5 are easy numbers because 2 is an even number, 3 is an odd number, and 5 is a multiple, you know, of 5. And things are multiple of 5. So you could start with 8 and keep on adding and see if you get the answer. That's a good way. Right? But each question is kind of unique though.
So sir, there's a method to find it fast up on anyone.
That's what I'm saying. You just look for the highest number. You could try that. But what I'm saying for this particular one, you could do, you know, for example, if you keep on adding 15 to check to see if a multiple of 15 is actually a multiple of 9, it's not so clear cut. So I'm saying, but like you have 2, 3, and 5. You understand what I'm trying to say?
No, sir.
No? What is 2? What type of number is 2? It's an even number. And what is 3?
What number?
An odd number. Right. So, I mean, if I look at that number there, is that number even number or odd number?
Odd number.
How do you know?
The 7.
7.
You look at the last number, right? So you look at the last number to determine if it's an odd or even. So what I'm saying, if you keep on adding 8, you can know what the number is odd or what? Even. And you can you know when a number is a multiple of 5, it always ends with either 5 or what?
0.
Or 0. All right, ma'am? So that's what I'm saying for this particular question. But for this question, it's a bit different. You know? But I suggest you know, you just if you're not so comfortable, shortcut or comfortable with a way of doing it, you just do it long way. All right. I hope you're following this. All right. Not getting a response, so I'm assuming that you follow it. All right, we're gonna look at what we call square numbers. I was just talking about this today in a class. All right. Square number. What are square numbers? Now, this might sound a little bit strange to you, but square numbers are actual numbers that can literally form a square. Like a literal, because we know that square is a four-sided figure, right? So for example, look at 4. Is 4 a square number? Let's test it. Can I form a square with 4 dots? Sure. So 4 is a square number. Is 6 a square number? Can I form a square with 6 backward? Or 6 matches?
The stick would be left.
Yeah, it's not, it will not give you a square, no matter how you put it. If you put it this way, like even like that way, oh, it's the same way, sorry. If you do it like this, you actually get, what do you actually get?
Rectangle.
A rectangle. Yeah, miss, I don't know. Whenever you speak, there's something in the background that is screaming out. I don't know what it is. Like there's some feedback. You know, I'm sure your background isn't noisy like that, but there's a feedback somewhere that's causing my ears to kind of pierce. Yeah. So, all right. So 6 is actually called a rectangular number. All right. Right. What about 9? Can you form a square with 9 sticks?
No.
I say yes.
All right, let's test it. Is it a square? 3,
Yeah.
3, 3, and 3. Yeah, you get a square. So 9 is a square number. All right, is 3 a square number? Can you form a square with 3 dots?
No.
No. All right. So that's what square numbers are. Okay, class? So another way of determining what square numbers are, you see, is to find the square root of that number. You guys know what the symbol means? It's called what?
Square root.
Square root. All right, so if you don't know, it's called a square root. So you have square and you have square root. Now the square root of a number is just a number when multiplied by itself gives you back that original number. So the square root of 100 is what? 10. All right. So 100 is a what? A square number, because when you find the square root of 100, you get a whole number. Mind you, suppose I said to find the square root of 101. On your calculator, you might get 10 point something, true? So 101 would not be a square number because you get a what? A remainder or a decimal. All right. What is the square root of 36, class?
6.
6. What you notice? It's a whole number, not true?
Yes.
Yes. So therefore 36 is a what? Is a square number. All right. All right, let me answer a question. Is 9, no, sorry, not 9. Is 16 a square number?
Yes.
Yes, because what is
Yes, sir.
the square root of 16?
4.
4. So 4 times 4 give back 16. All right.
4.
Let me do another test now. Is 49 a square number?
Yes.
Yes. What is the square root of 49, class?
7.
7. So 49 is a square number. All right. Any
So
questions?
basically, you're saying that any numbers that can multiply by itself to give you.
No, I wouldn't.
That's not it.
No, I wouldn't do
Any
that because any number can be multiplied by itself. True.
No, that's why I actually stopped.
Right.
So
So
any number. Go ahead.
all right. So you wouldn't you want to take it like this. You want to any number that you can find the square root of without
It's a
leaving
square
remaining
number.
number. Well, remember now, you can find the square root of any number. All right. But some numbers, when you find the square root of it, you don't get a remainder. You get whole numbers. All right. Now, when you can find the square root of a number and you get a whole number, then that is how you know that number that you find the square root of is a square number.
Square number. Okay.
All right. So, look at this. 12. Is 12 a square number?
No.
No,
No.
no, it's not.
If you find the square root of 12, you probably get
44.
no man, not square root. You get
Put
3 point something.
3. Yes,
3
3.
point something. All right. 3.46. Right. So once you get a decimal, it is not a square number. All right. Am I clear? Any questions?
Understood.
All right. Let me ask a question. Is 1 a square number?
Yes, it is.
All right. What is the square root of 1?
1.
1. Yes. So 1 is a square number. Why am I doing this? Right, so these are numbers when these are numbers when we, hold on, I don't tell you what. So when we find the square root of a number and the answer is a whole number, then the original number, notice not the original number, not the answer, you know. All right. Then the original number is called a square number. All right. Example. Now let us try to do this in order. So 1. One's a square number. What will come after 1?
4.
4. No,
Oh,
2,
yeah.
2 would not be a square number, you know, because if you find the square root of 2, you'll get 1 point something. So it's 4. What else?
8.
6.
Sure? No, man, it's a guess. Why is 6 is a square? 6 and 8 is not a square number.
9, sir.
It will be 9. Remember when I said that if you find the square root of 6, what are you gonna get? 2 point
Point.
something. You follow? What's the next number?
16.
It will be 16. And then
25.
Mhm. What next?
36.
Third. Are you guys seeing a pattern?
Yes, sir.
Then what? 49.
49.
And to go on, not true?
Yeah.
So actually, let me show you something. So it's like this one is actually 1 square. And then the 4 is what? 2 square. The 9 is what? 3 square, etc. So that's what's happening. So those are square numbers.
Oh.
Someone saying something to me?
I understand why you got those.
Oh, I got these?
No, I'm saying I understand clearly now.
Oh, you understand clearly now? Okay, all right, good.
Sir, the next number would that be 64 then after the 40.
Right, because this would have been 6 square. And 6 square is, no, sorry, not 6 square. 8 square,
8.
sorry. Yeah.
8 square.
8 square. Right, but it's not 8, it's a square number, is a product or the answer of 8 square, which is 64. And what will follow after that? What will come after 64?
81.
81, because 9 nines is what? 81.
81.
And then what will come after that?
100.
100. You follow?
Mhm.
All right, so those are what we call square numbers. All right. Okay, we're gonna look at what we call prime numbers or favorite. Is that so? Prime numbers. So prime numbers, so these are numbers where or when itself and one are factors. All right, so prime numbers are numbers when itself and one are the only factors. All right. Now sometimes person mix up this with odd number kind of something. All right. So example. All right, let me do this first before I say the example. All right, so is 6 a prime number? What we
No,
do,
sir.
you see, we write out all the factors of 6. So the factors of 6 are 1, 2, 3, and 6. So 6 is not a prime number. What about 7?
Yes, 7 is a prime number.
7 will be a prime number. Because what are the factors of 7? 1
1 and 7.
and
1
7.
and 7.
Yeah. What about 9?
3 is also a prime number.
No.
Hold on, 3?
Yes, it is.
You're right, because right, 3 is a prime number because only 1 and 3. What about 9? Is 9 a prime number?
No.
No, it's not.
It's not because you have 1. What else?
3.
3
And 9.
and 9. 11 is a prime number.
11. Yes. Is 2 a prime number?
Yes.
Yes.
Yes. As a matter of fact, it's only even number that is a prime number. All right. Okay, so let us try to see if we can get the example. So example, I'm going to try to get them in order.
Yeah, 1, 2, 3,
So we have 1, 2, 3. What will come next?
7.
5.
Would,
No,
would 5
5.
be a prime
Five.
number? 7,
7,
7.
11,
11, 13.
17.
7.
What was 17?
7.
Yeah.
17,
19,
19.
23.
23. What will come after that? 20. Oh my, miss. Hold on. Come on. Hold on. Why are so many persons mic open? Sarita, Maxine, Richard. Please mute the mic for me. Yeah, if you're not participating, just mute the mic for me. Maxine, please mute the mic. Otherwise, I'm gonna have to mute you. Thank you. All right. Even though your place is probably a studio, you're quiet, please just mute the mic. All right. Thank you. All right. So these are examples of
Good evening,
Prime.
sir.
prime numbers. Yes. Good evening.
Sorry for being late. I just got in from work.
Okay. All right. All right. So those are prime numbers. All right. Maxine, please mute your mic. One of his Maxine kids are pulling. Hindi kaya ano to? All right, guys, we're gonna look at fractions. All right. Yeah. Yeah, man. We're gonna look at fractions. So a simple definition, it's a part. A fraction is a part of a whole. So it's part of a whole. And a whole is actually one unit.
Sir, hold on, sir. Read about the prime number or something. The sentence no sound right.
Oh, that's all no. I'll just put in a V.
Okay.
Okay. All right. So, but you understand it though, you know? I mean, you know, you understand what it says, right?
Yes, sir.
Yeah. All right. So we're going to look at fractions. So a fraction is a part of a whole. There are a few things that we need to remember about when we're adding fractions. So note. So when we are adding or subtracting fractions, we have to find the LCM. All right. When we are multiplying fractions, we reduce to simplest form. Remember that anytime we are reducing fractions, we reduce in simplest form. All right. So we reduce
Sir, add the x to the fraction.
All right, boy. I see you guys are ardent language. I must apologize here. Sometimes when I'm typing and you know. All right, so when we're reducing, right? This should be when we are reducing, we do so diagonally and vertically. As we explain that. But not cross. When we are dividing fractions, change division sign to division sign, and we second fraction
Can you bring up the screen for me, please?
and reciprocate. Sure. And then reduce. All right, let me know when you're finished writing, yeah?
There it was.
Sir, when I'm ready for wear glasses, if they can bring it up a little better, bigger.
Oh, no, sorry, no, something go happened a while ago. I don't know. Sorry about that. Oh, that look. Wait, what's happening? Oh, so what happens? Like the mouse keeps on, is that keep when it slides? I don't know what happened. So it slides there.
When you're ready, sir.
All right, cool. All right, so all right, I hear somebody way in the background, like them at the back of the class. I said, hold on, sir. All right, 30 more seconds, all right? All right, so I'm sure you guys are finished. All right, so I'm just give me a second. I'm gonna search for a document. All right. Can find fast. Okay, just locate the document. My computer is a bit slow here. So bad. By the way, you have this. You guys have actually have this document that I have here. Remember I sent some papers to you. Some whole heap of documents, right? Why is it not coming up, man? Okay, I'm in. Okay, I'm going to share. Sorry about that. All right. So we're going to look at this question here. Everybody see the question?
Not right now, sir. It's gray.
Oh my, let me what's happening here? Hold on, let me check it. Are you seeing it now?
Yeah. Yes.
All right.
Yes.
Okay, hold on. I think something happened.
Yes, sir.
I don't like this. All right, right, give me a second. I think. All right, see it now? All right. Okay, take all this question from me, please. All right, let me know when you finish.
Yes, sir.
All right. Give me another yes, sir, and then I'll two more yes, sir. I need two more yes, sir.
Yes, sir.
Yes, sir. All right, cool. Now, if you're right, if you're still writing, please hurry up here. Because I know how it is sometimes. All right, so to answer this question, you see, is that we convert these mixed fractions to improper fractions. All right. Now, well, we know that what an improper fraction. We should know what an improper fraction is. So for example, 7/3 is a improper fraction. So improper fraction is when the numerator is bigger than the denominator. All right. And how would I convert this improper to a mixed fraction? I would say how many groups of 3 can we get out of 7? Would be 2. Right about the denominator, and the remainder would have been 1. So you have 7 stuff. 3, 4, 5, 6, 7. All right, how many groups of 3? 1, 2. So the remainder always go on top. Okay. So if I have 5/3, what would 5/3 be? Somebody as a mixed fraction.
1
One.
and 2/3.
1 and 2/3.
1 and 2/3. All right. And if I give you a mixed fraction, you guys should be able to look at this mixed fraction and write it as an improper fraction, like, you know. So for example, if I want to get from here, this mixed fraction back to that improper fraction, I would simply say 1 times 3 is 3, and then add 2 to it to give me 5 and write out the same 3. You follow? What is 3 and 1/3 as an improper fraction? Somebody.
6/1.
Try again.
10/3.
It will be 10/3. 3 3s is 9. And 9 plus 1 is 10. Are we clear? All right, so do me a favor. I want you guys to transform all these mixed fractions to improper fractions. So do that for me. 1 minute to do that. And nobody should be using a calculator. I'm going to step away for a minute, all right? What's 1 minute? That's me back. Okay. Mrs. Johnson Peart, are you finished? You want to tell the class what you have for those improper fractions?
You're referring to me, sir?
Yes.
All right, sir.
Unless that's not you.
Jamison Peart?
Yes.
Okay.
All right.
So my improper fractions are 23/7,
Mhm.
5/3, and 8/7.
I think the battle is now brewing between two corporate area companies and 9 of the rest.
All right. Thank you, Miss. Thanks for participating. You're absolutely correct. Is she correct, class?
Yes, she is.
Yes. All right. Now, what we're going to do is, we're going to work the bracket first. All right. Now, what did I say in the note? Let me go for the note. What did I say? When we're adding and subtracting fractions, what do we do, class? We find the
Lowest common factor. Multiple, sorry.
no man. Multiple. It would be multiplier. It would be factor. All right. Thank you. All right. Now, so what we're going to do is that we're going to work out this. Probably should have put this up to the left. Oh boy. All right, tell you, let me just. What's happening there? All right, so we have so we're gonna work on the top piece. Can someone tell me what the LCM is? Of 3 and 7?
21.
Right. So what we're gonna do now is that we're gonna say 7 into 21. How many groups of
21.
right? We're gonna say how many groups of 7 we can get of 21. That will be
3.
3. And that answer goes to the top of this. All right. And then we're gonna multiply 3 times 23 is 69. And then we're going to say 3. How many groups of 3 can we get of 21? And that will be
7.
7. And then we say 5 sevens.
35.
35. Is it what the following so far?
Yes, sir.
Sir,
Mm-hmm.
the denominator.
Mm-hmm.
Can you go back down there, so please?
All right. What you're going to do is that you're going to find the multiples of 3. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24.
Oh, okay. I could do the same thing with 7. Okay.
Right. Should I stop? Or are you following?
You can stop.
All right. So what is 69 plus 35?
104.
104. And then we write by the 21.
Yes,
Alright?
sir.
So now when we work out this bracket here, class, the answer is 104 over 21. Now we don't need to put it into a mixed fraction. You know why? Because we don't complete the question yet. All right? But then now it says divide by 8 over 7. All right? Is everybody following me so far? Anybody lost?
Yes, sir.
All right.
Last.
All right. Tell me.
I think I got the
Sir,
idea.
where did the 8 from?
All right, you're gonna say 1 times 7 is 7, and 7 plus 1 gives you 8.
Oh, okay.
All right. Let us go back to the notes or notes.
I think I solved it reading the notes.
Hmm?
I think I solved it reading the notes.
You think you?
Repeat.
No, you're kind of breaking up.
I said, I believe I solved the problem using the notes.
Using the notes. Yes, man. That's what that's what the notes are for. No? All right. No, it says when we are what? Dividing fractions, what do? We change the division sign to a what?
Multiplication.
Multiplication, and then we reciprocate. No, what's another word for reciprocate? Flip. Not true. The second fraction. Notice the second fraction. All right. Right. So that's what we're gonna do. So what's happening? Right. So we're gonna change the division sign. So I'm sorry, it looks a bit jumbled. Oh boy, I have to go in the question. So we're gonna have 104 over 21. Change division to a what? A multiplication, and we reciprocate the second fraction. All right. Are you guys following?
Yes, sir.
All right. Talk to them. About wait till I'm done is your last. Is everybody following? Any question? Is any part of it you're not getting? Talk to me, because I'm going to ask you to do one by yourself. All right. Let's go back to the notes. It says when we are multiplying fractions, what do? We reduce or break it down or cancel in its simplest form. All right. And I also mentioned that when we are reducing, we do so diagonally and vertically, but not across. Let me explain that. So diagonally means like this. We can cancel like that. That's what diagonally means, yeah? Vertically means that we can cancel like this. We can go so. All right? But what we can't do is to reduce like this. We can't say 7 to 104. We can't say 18 to 21. We can't do that. Everybody following? All right. Now, would you agree with me that we can cancel the 7 and the 21? So
Yes, sir.
that's
Yes,
one.
sir.
That's 1, and that's what? 3.
3.
All right. 8 can actually go into 104. Watch carefully. 8 into 8 goes 1. 8 into 10 goes 2. All right. And remainder 2, right? So the 2 goes 24. And 8 into 24 goes what? 3. So our answer is actually 23 over 3. Or we can reduce that, right? What is this as a mixed fraction?
One and 7 over 3.
Could do one.
Hold on.
7 and 1 over 3.
7 and
4 and 2 over 3.
Oh, sorry. Yes, 7 and 2.
Sir?
Yes. Hmm?
The FDA authorizes booster shots for 2 COVID-19 vaccines. Please stay with us.
Sir,
Go
Sir,
ahead.
28 into 104 was 23
Is
times.
not 23 times exactly.
13 times, sir.
Oh, it's 13 times. Oh, I'm sorry. I'm sorry. I'm sorry. It's 13 times. One time, not true?
Yeah.
Yeah. Sorry about that. So it's gonna be 13.
Because my
over
answer is 4 and 1.
13 over 3. So your answer would have been what? Or 4
4 and 1 over
and 1 over
3.
3. All right. Remember, you don't get extra marks for doing this. All right. So it's either either. All right. It's either either. All right. Do we have
If the
any?
question is saying to leave it as mixed fraction, right?
No. The instructions is to leave it in its simplest form, not as a mixed fraction.
Okay.
Unless it says to leave it as a mixed fraction, and I have never seen something like that before.
Yeah. Yeah.
All right. Anybody writing?
Yes, sir.
All right. I'm gonna give you 2 to try.
Well, last time I done right.
No man, I'm not gonna change it, man. Don't worry. You want me to do another one, or you want to try 2?
Do another one,
I
sir.
want to try.
What you want next one?
All right. I think the majority says I should do another one, so I'll do another one. Okay. What time is it now, class?
7:34.
Yes, 7:34.
All right. So we're gonna do these 2 questions and take a little break, and then we're gonna go back, continue the work. Right? After fractions, we're gonna look at what we call ratio and proportion and percentages. I think we're gonna finish this unit today, all right? Yes. So next week we're gonna start a new unit. All right. You will be getting a short test next week. All right. Okay.
So sir, for those who just started, how will we get that information? The previous information, that is.
It's in the class recordings. Are you in the WhatsApp group? When did you join the group? The WhatsApp group?
I'm not in the WhatsApp group as yet, sir. I just started class since night.
Oh, you're from Holy Childhood?
No, sir. Westmoreland.
Oh, Westmoreland. Oh, what the place name again? You said you were living somewhere.
Seaford Town.
Seaford Town. Like I know where that is. Can you message the principal? I don't know if she's up. Or you probably wait till tomorrow then, all right? Wait till tomorrow.
Okay, sir.
And message the principal. What I can do, because I post them on my YouTube channel, what I can do is to post my YouTube channel in the chat, and you can probably go to it. And the last 3 videos that I have would have been the class recording. Okay. All right. Now,
Okay, sir.
okay. Now I want you guys to put in the chat. We're gonna start a new unit next week. Now it's either going to be algebra or financial mathematics. Financial mathematics has to do with profit, loss, hire purchase, sales tax, foreign exchange. Algebra is just like an abstract is algebra. All right.
Question,
So
financial mathematics, is it something new?
No man, I said profit and loss, foreign exchange. That doesn't sound new to you. Come on, that's not a new topic.
I don't remember learning that. That's the reason why I asked.
Really? You haven't done profit? You have never learned profit and loss?
Mm,
No?
I
What
can't
about
recall
what
right
what
now.
about discount?
It's the same as
Can't
simple.
recall.
Simple interest, compound interest. Look like when much time I keep money, you look like your school class.
Girl, sir, it's been years.
In years, yeah. But yeah. It's called another term for it is consumer arithmetic. All right. So I want you guys to put in the chat and tell me which you prefer for me to start, whether it's financial mathematics or algebra. All right. So just post in the chat, and based on the numbers, I will take a vote and make a decision.
Even Mr. Stevens.
Yes, sir.
Yes, Adrian here. Would either of those topics be in the exam?
Yeah, man. Both of them. But I'm just giving an option to. It's either, you know. So let's put in the chat which one you prefer to start with. But it's either algebra, because if we start with algebra, then the next one will be financial mathematics. If you start with financial mathematics, then it will be algebra. I must tell you, algebra is a little bit harder and longer. You have more objectives in algebra. And it's very abstract, lots of X's and lots of Y's.
I'm a 1.5 book page of work notes, sir.
Again, well, I mean, not for a lot of questions, no, because what happens, CXC is changing now. CXC, if you notice, if you look at the past 3 to 4 past papers, paper 2, the working out is not so much. It's pure 1 mark and 2 mark. So they've shifted their emphasis on long working out. If you notice on a 60 paper, it just only go one part here, so I'll go one part here, so I'll go one part here. All right. All right, so put in the chat which one you prefer.
Right now, algebra biggest gunman, you know. Anyway, catch me, stick me. I can't do nothing to that. Rough me.
Okay.
In a rough for me, but it just long. It take a long process.
It's a long it's a lot of objectives and financial matter. Financial matter is more friendly. It's something you can relate to. It's something that we do every day. You know, if I said to work with the profit, you know, a shopkeeper buys 10 packs of sweets, sold it for that amount. What was his profit? You know, a man invested 300,000 US at VMBS for 10 years. What is his return? That kind of thing.
Sir, what a whole heap of formula we have to remember? Formula them to work out them, and then them not come with formula.
Yeah, man, they come with formulas. But yes.
For the, I think maybe the young lady that was asking when you're referring to financial maths, maybe she know it as arithmetic.
Arithmetic. Okay. Okay. I don't know, you know. I don't know. Probably. All right, so I'm gonna take this off. I'm gonna ask you to try 2 questions. Oh, Claire, before I continue, see what you notes about this? I just want something not true. But if you're to look at this question I'm gonna give you. Whoa, what's that?
I can't name the Yagui, sir.
Hmm?
I'm not a Yagui. You're gonna do one, right?
All right. No man, you said I should do one, not true. So I'm gonna do one. I'm gonna do one for you. Don't worry yourself. Single spot. All right, so all right, so what you're gonna do is it's the same thing. Work on the top piece, work on the bottom piece, and then what? Divide it. All right. So let's look at the top piece. What symbol is that, class? Multiplication. All right. So remember, when we're multiplying, what do? We cancel. Look at the bottom piece. What's that? Subtraction. So we want to find the LCM, not true? All right. So what we're going to do is that we're going to convert all these mixed to what? Improper. All right. So go ahead for me and do that. And do you notice that basically they're the same numbers, same values? All right. So go ahead for me and write out the improper fractions for this.
It's 10/3.
Hold on. Let's give everybody here. Let's give you can go ahead. I'm gonna give everybody 30 seconds and then you can tell us, all right? Okay. All right. Thank you. All right, Miss, go ahead for me, please.
Okay.
10/3 times 6/5.
Same thing here, isn't it?
Yes.
Thank you. Everybody get that? All right. Let us reduce the top piece. So all right, let me use a different color. So the 3 and 6, so 3 to 3 goes 1, 3 to 6 goes 2. Everybody see that? 5 into 5 goes 1, and 5 into 10 goes 2. So what happens when everything finished now? Just multiply across. So 2 times 2 would be 4. So, and 1 times 1 down here, so it would be 1. So the answer for the top piece is 4/1. Any questions? All right. The bottom piece now, what we're going to do is that we're going to find the LCM because we're subtracting. The LCM is what? 15. Now 3 to 15 goes 5. 5 times 10, 50. 5 into 15 goes how many times, class? 3 times?
3.
How much 3 6s?
18.
18. And what is 18 from 50?
32.
So this is 32 over 50. All right.
Sir, do over bottom part. I don't catch it.
All right. The LCM, please mute the mic for me, please. The LCM is 15. Do you see that? You saw get that? The LCM of 3 and 5 is 15. Are you there, ma'am?
Yes, sir.
Do you see we get the 15?
Yes, sir.
All right. And do you understand why we're finding the LCM? Why are we finding the LCM?
Sorry, it's the rule.
All right. All right. So the rule says that whenever we are adding and subtracting, we need to find the LCM. That's true. All right, ma'am. Are you there? Okay.
Yes, sir.
All right. Then you're gonna say 3 into 15. What's 3 into 15, ma'am? How many groups of 3 can you do 15?
5.
And 5 tens? All right. You following so far?
Yes, sir.
And you do the same thing for the right hand side, yeah? All right?
I get you, sir.
All right. Okay, thank you. Awesome. No. So the answer for this piece is that. All right? But what does this big sign represent, class? Starts with D.
Division.
Division or divide, not true? No. Watch carefully. Listen carefully. The answer you get for the top piece stays to the left. So it's going to be 4/1 divided by 32/50. All right? Are we clear? No. Is it because sometimes because this is what you work out last, we tend to put the answer for the last piece to the left, which would have been incorrect. All right? And then now, how do we divide fractions? What do we do, class? Change division, right?
Reciprocate.
Reciprocate, right? Or flip. And change division to multiplication. And remember, which of the fractions do we reciprocate? Is it the first one or the second one?
The second.
The second one. All right. And then no, we cancel because we're multiplying. And as we can see, can 4 go into 32?
Yes, sir.
8 times.
All right. How many times?
8 times.
Right. Can anything else cancel? Can
No,
8 go into
sir.
15? No.
Oh, yeah.
So,
You're going to leave a remainder.
right. So when nothing else can cancel, you multiply across. 1 times 15 is 15. And 1 times 8 is 8. All right. And then if you want to, you can write it as a mixed fraction. Someone tell me what is this as a mixed fraction?
1 and 7/8.
Awesome. Very good. So these are our answers. Any questions? Anybody writing?
Yes, sir.
All right. Let me give you a minute to write this off. My God, everybody's algebra. Not one of you said, Adrian, I think.
Yeah, but I mean the majority vote.
Yeah.
was-
Oh, yeah. Look on. All right. Cool. Hey, you ever watch scary movies? And when they hear and see danger, they go towards it. Not true. You always wonder why. You ever wonder why? It's like the more you think it's scared, they go towards it. Right. So it's something like this. It's something like this. It's something like this. All right. You guys are taking on the algebra, the harder part, which is commendable. All right. Let me tell you, with algebra, that's when you're gonna have to start to study and practice maths. Because one of the problems with algebra is that some of the topics, they're so close. All right. they're so close that one, you need to be able to recognize a question. After recognize a question, you should be able to know which technique to use to solve or simplify it. And I think that's the biggest problem. Because when you get to exam, all you see are one big XY, so XYZ, and you want to know what's the difference between that one and that one. So it takes practice, all right? It takes practice.
Tell to find X and they go wait 1.5 book pizza to find X.
Oh man, so that's the university maths, man.
We don't need to find X because she gone a long time. Future we have focus on.
Okay.
All right.
Okay. Well, it could be a heat, Joe. All right, can I take this off?
Yes, sir.
All right, is there anybody writing? Before I close it, does anybody have any question about this? Anybody at all? Is there anything that you're not sure about? All right, I'm gonna close this, all right? All right, so I want you guys to try these two. Hold on. All right, try these two for me. I'm gonna give you 7 minutes. Oh, boy. Can you see it properly? All right. Yes, it is similar to yes, simultaneous equation comes on the algebra. Okay, yes, Keandra, I'm seeing your message. Okay. Okay, so I'm gonna step away for about 7 minutes and I'll return, okay? Does anybody have any question? I'm gonna randomly call on persons to do parts and pieces now, like different parts and pieces, okay? Is that okay with you?
That's good with me.
Or you want to volunteer, or you don't want that pressure? All right, let me not pressure you.
Randomly, sir. See what we are learn.
Okay, all right. What's your name?
Franklin.
All right. Cool.
Make sure call her first.
Hello? Hello? Okay, then. I guess I'm alone.
Yeah, we're going.
Yeah. Mr. Stephen?
No, think sir take a break.
Yeah. But just want to check if me answer them right.
I guess left till we are work it out because you know
Me get 21 over 20 for the first one, and 29 over 35 for the last one.
I don't think you should shout out the answer in the group, you know, because you know people still working
Oh.
it out. Wise way to shout the answers up like that. You know,
Oh,
so I guess when he return, we can work it out and we see if you're right.
All right. Yeah, anybody have any questions? I step away for a little bit. Okay, yes, Forrester saying that she finished. All right. All right, guys. How are we staying? How we stay? Can we proceed with number 1, number 4, the first one?
Oh, I'm not sure if my number 1 is right.
All right.
I got 21 over 20.
21 over 20. It sounds correct, man. Yeah, it sounds correct. Anybody's got 21 over 20 or 1 and 1 over 20?
Yes, sir.
I was just going to ask
Yes.
if you could go it down to 1 and 1 over 20, but that's the answer I got as well.
Yes, it is correct. Awesome. So let me just quickly do this. This 12 over 3. Subtract 11 over 6. LCM is 6. So that's 24. That's 11. That's 13. Am I correct?
Sir, one question.
Sir,
Sir, one
20,
question, sir.
not 24.
Sir,
It's 13, not 12.
Huh?
sir, it's supposed to be 13 over 12
13
over
is
3
what?
of
It's 3.
Oh,
because it's 3
oh.
times 2
Oh
plus
yeah,
1.
yeah. That means we have wrong foolish is true.
Yeah.
Who say it?
Sir, my answer is 15 over 6.
All right. Okay, yeah, man. So it's 15 over 6. All right. And the bottom piece is gonna be what? 10 over 7 times 5 over 3. Nothing can cancel, not true? So you multiply across. That's 50 over 21. Correct?
Yes, sir.
Right. So remember now, we're dividing, right? So this, the 15 over 6 stays to the what? The left. Change the divide to a multiplication and reciprocate this fraction here. So it's 21 over 50. I can use 3 into 6 goes 2. 3 into 21 goes 7. I can use 5 here, so which is 3. What is that? That's 10. So that's 21 over 20. Or 1 and 1 over 20. All right. Put in the chat and tell me everybody who got that. Put it in the chat. I need to know all the persons who got that.
Now how you get 21 over 20? Oh, you multiply across. Oh.
Yeah, when nothing else can cancel, that's what you do. All right, so put it in the chat and let me know if you got that. All right. Okay. I'm seeing. Yes. Machine. Forrester. Marsh. Richard. Akira. Camille. Mrs. Camille, that is. Stacy Ann. Marlene. Carlene. Okay. Awesome. All right. So if you haven't gotten that, just double check your thing. All right. So thank you for participating. Let's move on to, can I close this? Anybody writing this out?
One moment, sir.
All right, no problem. Let me know when I can close here.
Finish.
All right, thank you, sir. All right. Let's look at this one now. All right, so Mrs. Clark Lemon, are you there? All right. Emily, are you there?
Sorry, you said Mrs. Clark?
I see Clark Lemon.
Oh.
Owana. You're a Mrs. Clark too?
I'm a Miss Clark. That's why the actually is like Mrs. Clark.
Okay. All right. So you want to try? Miss Clark?
I can.
All right, go ahead.
Okay. So 23617 over 3. Plus, and you're gonna put back the 3 over 7. Okay. Common factor, common multiple. We keep on as a factor. Hold on. I'm gonna go back in my book. I have 21, sir. I don't know if that's right. Okay, the right? Okay. So 3 into 21 is 7. Watcha. All right. Street 9. 49 plus 9 over 21. 49 plus 9 hour.
58.
58. Okay. So put that one side.
All right.
And we're
Thank
going.
you. No, I'm gonna ask somebody else. So thank you so much. All right, Davin, can you continue? Or Davin, you wanna continue?
Yes, sir.
All right, go ahead, son. That's this part here.
Alright. So we're gonna say 3. So we're gonna divide 3, 2, 6, and 1, 7. So we're gonna have 7 over 3. Divide by 7, 1, 7, 8, 9, 10 over 10. So now we're gonna cancel out the 7 out of 7, and 3 into 10 cannot be cancelled. So we're gonna do it. There we go.
All right, thank you, sir. Awesome. Yeah, man. Yeah, man. Sarita, are you there? You want to finish the question? Sarita. All right, Tamar, are you there? No? Yes? All right.
Sir, you're going leave the 10 over 3 and flip the 28 over, put the 21 over the
Yeah, man. I'm just trying to get some participants, but they're not responding. We're gonna work it out here. Brittany, are you there?
Yes, sir.
You wanna finish? All right. Is that a yes or a no? No?
No, sir.
All right, no problem, no problem. Luciano, here I come, Ja. As I call, you want to finish it?
Still working it out. So I haven't.
Still working it. All right.
Sir, can I try?
All right, go ahead, ma'am.
Okay, so you would have 58 over 21. Times, you would then flip it, so you would have 3 over 10. And then you would see what you can cancel out. So it would be 3 into itself, that is 1, 3 into 21, 7. And
I'm sorry, not to cut, but sir, can you pause a bit? Why would you? I thought we only flip when we were dividing. No, so.
Yeah, but what is this? It's a divide. It's a division, isn't it? That means divide.
Oh, so you're talking. Okay, all right, go on.
Continue, miss.
Sir, I'm seeing that you crossed the 10. I did not cancel out that.
We can use 2.
Can use 2.
So
Okay.
2 into 10 goes 5. And 2 into 58. What's 2 into 58? 29.
29.
Right. So what's the answer now?
It will be 29 over 5 times 7. 7 times 5 is 35. So it's 29 over 35.
That's the answer. All right, any questions?
Yeah, I thought I might have missed there. Why you flip it at where it says?
Why do I flip it?
The answers. Why you flip it again? You can just remind me of that.
All right, so let's go again. According to the notes, right? It says when we're dividing fractions, we change division to a multiplication and we reciprocate. So that's the reason why.
I think what's confusing, sir, is because there was a multiplication there. So, but you're saying that because
hold on, that's my answer here. Sir, are you following? That's the rule.
Yes, I am.
When we're dividing, what do we do? I think I didn't really, okay, I think probably because we didn't show it. I think probably that's the reason. But actually, it's 58 over 21 divided. So is it the symbol here? That means to divide.
Oh, yeah, that,
Divided by 10 over 3. And then we change this division to this multiplication. And the 10 over 3 becomes this 3 over that 10. But at the start, everybody would probably get this right.
oh yeah, I get that line before you write out
Yeah,
the
man. You would have to do this in the previous question, not true?
Right.
Yeah, man, it's the same thing. You following now?
Okay, I'm clear on that now.
Yeah, man. All right, good. Yes, Miss. Is it Miss Clark?
Yeah, I was looking at it.
Oh, I'm sorry. Yeah.
But it's much clearer.
It's much clearer now, yeah. Yeah, I forgot to put this in. My bad. Miss Clark, go ahead, please. You're saying something?
No, sir, I was basically saying the same thing. That line really, sometimes when I remember, well, I didn't remember then. Let me say that.
All right, so you should remember, right? All right. So the line is,
Okay,
yeah, the line means divide. All right. Can I take this off? Anybody writing? Going once, twice, thrice. Okay, I'm gonna take this down. All right, so.
Sir, question.
Yeah, yes, sir.
So in other words, when you just see the question for the first time, you could say that the bottom side, once you get that answer, you must always flip it, correct?
No, don't say bottom side, because what happened? All right, look, let me take back to the question. When it's a bottom side, you're not talking about the bottom piece, all of this. It says, the rule says that when we're dividing, we change the division to a multiplication and flip or reciprocate the second fraction. All right. But those are bottom, because when you say bottom piece, you might be referring to the bottom piece of this. All right. All right.
Okay.
I think I want to give you another one to try just to see the deal. All right, look at this one for me, please. 17. Try it for me. You see where the 3 is? Put 3 over 1. Try number 17.
Sir, we're not seeing it.
Oh, sorry. I don't know why I unshared that while ago.
Mr. Stevens, if you could just remind me what the topic was again.
Fractions. We're doing fractions. Okay.
Dropped in a bit late coming in from work.
Okay. All right. So are you seeing the screen now?
Yes, sir.
Yes.
Yes, sir.
Yeah, as I was saying, you see where the 3 is? Put 3 over 1.
Okay.
All right. Someone saying something? All right.
Yes, sir. Repeat what you were saying last about the 3.
Put 3 over 1. All right. Write the 3 as 3 over 1.
Okay, sir.
All right, one more minute to wrap up this question. Anybody finish?
Yes, sir.
All right, what you got?
Me, sir, you're asking me what I got?
Yeah, man, yeah.
41 over 15 or 2 and 11 over 15.
111 or 15. All right, anybody got that?
Yes, sir.
Okay,
We're
cool.
working on it.
Still working on it. All right. If everybody get this now, I don't need to work this out, correct? What do you say about that?
No, sir, do
Correct.
work the same way.
You got it wrong?
Yes, sir, do work now.
Okay. What you got? Or you didn't do it?
I do it, sir, but I kind of fumble on some part of it.
Where? For example. Look back, look back and check, man. Look back and check. Novia, you wanna give that a try?
Yes, sir.
You want to try it? Or you want to try part of it?
Okay, sir.
All right. I'm just gonna let you do the convert to the thing. So that's 2 or 3.
So I have 2 over 3 plus 9 over 7.
Mm-hmm.
And I got 21. So I say 3 into 21 goes 7 times. So 7 times 2 equals 14 plus 7 into 21 goes 3 times. So 7 times 3 equals 27. So it is 14 plus 27 equal 41 over 21.
Awesome. Thank you. Forrester, are you there?
Yes, sir.
You wanna continue? Bottom piece here. Yes, no. All right.
All right. So I have the 3 over 1 minus the 23 over 7.
Take it 23.
Because my times 7 2 is 14 and then I add it.
So it's a 23 or whatever.
Oh.
Yes.
Sorry.
Okay. What's LCM?
Seven.
57, sir.
Yeah. Continuous. You want to stop?
Then I take away 3, 16 from 3. Yeah, I get 13.
Hold on. I think you broke up a while ago. We weren't hearing. Go again.
I'm gonna take away the 3 from the 16 from the 3. That give me 13.
Hold on. So you're saying you work out these two?
Yeah.
All right. Well, I mean, that's what you did for up here. So did you got 41 over 21 for the top piece? No, I
No,
think,
sir.
no.
No.
You got 9, not true? 9 over 21, not true? No, you got 11 over 20. You got 11 over 21, not true?
Yeah.
No, you're doing something wrong. Because what happened? You missed a step. After you find the LCM, you're gonna say 1 into 7 goes 7 times, and then 7 trees is 21. It's a good thing we couldn't do that question because I would have moved on and you should have lost you. All right. So 7 into 7 goes 1 times, and 1 times 16 is 16. So it's actually 16 from 21 and not 3 from 16. Okay, Mom? I hope you follow it. You have any question? All right. So I'm kind of surprised how you just saying all of that, because we would have done some third example, and we haven't done that. We haven't. The thing about it, you see, when you're doing fractions, you know, when you're adding and subtracting, you can't make up your own thing. You have to go by what the rules say, right? So you can't say, boy, sir, 2 plus 2 are 4 and 3 plus 7, you can't do that. All right. So it's like you're making up stuff. Okay. All right. Thank you anyway still. Marlene, are you there? Ms. Richardson?
Yes, sir, I'm here.
You want to finish it? You want to finish the question?
Sure.
All right. So I don't have enough. Hold on. Enough space, man. Wait. I have enough space, man. We can move in, basically. All right. So the top piece is 41 over 21. All right. And people, remember that this bar, what does this bar represents?
Divide.
Divide. Divide by what? 5.
5 over 7.
Over 7. All right. Take it away, Ms. Richardson, Mrs. Richardson.
All right. We're gonna go ahead and reciprocate. So that's gonna be 41 over 21.
And
Times.
We need to change that sign, not true?
Yes. 7 over 5. All right, and then we can cancel 7 and 21. So 7 into goes 1, and then 7 into 21 goes 3. And 41 times 1 equal 41. And 3 times 5 equal 15. So it's 41 over 15, or 2 and 11 over 15.
All right. Any questions?
Yes, sir.
All right, go ahead.
Why my last? Mr. Sot. The top part, so the first half of the fraction, right? I believe where I went wrong is the fact that I tried to simplify. So, that 2 and 11 over 15, how you come up with that?
Hold on. The 2 and 11 over 15 is coming from the final answer. Did you answer how we get this?
Yeah, I simplified, so I didn't get that. Boy.
You simplified this?
No, before that, so I had the 2 over 3 plus the 9 over 7. That's up at the top, right? That I didn't do that part. So that 14 plus 2.
No, it's 27.
Plus 27. Yeah. Okay. Sir, how you come up with that?
With what?
All right, yes, I'm last enough.
Where? Which
Yes,
number? Which number?
All right, so I'm at literally I'm at the 2/3 and the 9/7. What's next? I see the four. You have the 14 plus
No,
the
the,
20.
no, the first thing you do have to
So
find.
what you do? Multiply the denominators for the to get the 21.
No, man, you have to find the LCM. You remember we were doing LCM earlier on today? Find the LCM of 3 and 7.
Yeah.
Yeah, man.
Yeah.
Yeah. And then 3 into 20, 3 into 21 goes 7. 7 2 is 14. 7 to 21 goes 3. 3 9 is 27.
It's 27. Right. Okay. Okay.
Yeah.
All right. I'm going to do some homework. All right.
All right. So there we go. Okay. Any more questions? All right. Someone tell me what time is it?
8:40 on the dot.
8:40. Okay. All right. Thank you, sir. All right.
8:40.
Okay. So we're hold on. All right, guys. So